Welcome to Spring LIB.
In this exercise, we have a crate that has a mass of 12 kilograms that slides down an inclined plane that makes an angle of 30 degrees with the horizontal with an initial speed of 2.5 meters per second. The length of the inclined plane is 3 meters. And the kinetic friction coefficient between the block and the plane and the surface is 0.3. Given this information, our goal is to find what is the final speed v of the block when it reaches point B. So in order to solve this exercise, we need to briefly review how to handle inclined plane problems. Okay, so consider that we have a block on an inclined plane. So here we have the block. The inclined plane makes an angle of theta with horizontal, and the block has a mass m. Well, in that case, we can decompose the force that acts on the block into two components. One that is parallel to the surface of the inclined plane, and the other one that's perpendicular. And the resultant of these two forces that I'm drawing here is the gravitational force that points downwards. Okay, I'm simply decomposing the gravitational force. So the component that is parallel to the surface, I'm going to call x, and the other one I'm going to call y. We have that the force in the x direction is equal to mg times sine of theta, and the force in the y direction is equal to mg times cosine of theta. Notice that the force in the y direction is equal to the normal, that is, the force that the surface exerts on the block. Also, remember that the friction force is equal to the coefficient of kinetic friction, mu k, times the normal force m. Okay? So our goal is to find the final speed v. In order to do that, let's first find what is the acceleration of the block as it slides down the inclined plane. Notice that the acceleration in the y direction is 0 since the since the block does not move in the y direction. Okay, so the normal is equal to the force, the magnitude of the normal is equal to the magnitude of the force in the y direction, the gravitational force in the y direction, and this is equal to mu k mg cosine theta. Actually, I'm sorry, this is the friction force. The normal force is just mg times cosine theta. Sorry for that. This is in the y direction. In the x direction, we have that the sum of the forces is the force in the x direction, the gravitational force in the x direction, minus the friction force in the x direction. And this is equal to m times a. A is the acceleration of the block. Now fx is mg times sine of theta, while ff, that is the friction force, is mu k times the normal, which is mg times cosine of theta, and this is ma. Notice that the m's cancel out, so we're left with a is equal to g times the sine of theta minus mu k times cosine of theta. This is the acceleration of the block. Now we know from Torricelli's formula that the speed of a block that starts with a speed v0 and has an acceleration a is such that v squared is equal to v0 squared plus 2 times the acceleration times the distance traveled. In our case, we want to find v, so v is equal to the square root of v0 squared plus 2 times a, which is g times sine of theta, minus mu k times cosine of theta times delta x. Now v0 is 2.5 meters per second. I have to square it, plus 2 times 9.8 meters per second squared times the sine of 30 minus 0.3 times the cosine of 30 times delta x, which is 3 meters. That's the length of the inclined plane. So v is equal to 4.51 meters per second, which is the answer to our exercise.